This is a repair demonstration for Pelonis Air Circulator Model FB50-9HA and is divided into chapters for those who are looking for specific information and content. The problem with the fan was that when I turned it on, it would start very, very slowly, and sometimes it took about a minute to operate at a normal speed. So clearly, there was something wrong with the fan, which required it to be repaired. The reason why the fan started slowly was because it needed basic maintenance. After my repairs by disassembling and cleaning the motor parts and lubricating the rotating shaft, the front bearing, and the rear bearing with Zoom multi-purpose turbine oil, the fan now starts and operates normally with no problems. And take notice how the blade continues to spin well after I turn off the power to the fan. A DeWalt impact driver with a star head tip, Zoom multi-purpose turbine oil, one Black & Decker dust buster, disposable foam and cotton swabs, microfiber cloth, one star head screwdriver, one flathead screwdriver, two picks, a pair of locking pliers, a black permanent marker, a black rubber mallet, 3 normal sized bungee cords, 1 small bungee cord, and black rubber gloves. Ensure that you are using a non-detergent oil such as Zoom Spout Turbine Oil to lubricate the bearings. Do not use WD-40 because it is a solvent, water displacement, and cleaning product which leaves a residue that has potential to seize the motor or jam the bearings over an extended period of time. Unplug the fan and bind the cord with a small bungee cord. Secure the fan to the table with the 3 bungee cords. Remove the 2 tilting adjustable knobs. Remove the fan from the base. Loosen the screws in the rear guard with the star head screwdriver. Remove the screws from the rear guard by tapping on the front guard. Separate the front guard from the rear guard. Secure the rear guard to the table with a bungee cord. Remove the blade cap nut with the locking pliers. The only two methods that I found to remove the blade assembly causes damage to the threaded insert, as I was unable to remove the blade assembly just by pulling it off. Both of those methods requires inserting a pick or flathead screwdriver into the small hole in the threaded insert next to the shaft and rotating the blade clockwise, which I'll demonstrate in following steps. After I did this a few times, the threaded insert is now loose and the blade is easy to remove from the rotating shaft. As a result, I added a washer behind the blade cap nut to manage and control the blade assembly looseness and excess vibration. So if you know how to remove the blade assembly without causing damage to the threaded insert, feel free to explain in the comments below. Attach the locking pliers to the tip of the rotating shaft and spin the blade clockwise until it touches the pliers. Insert the tip of the pick into the small hole and turn the blade clockwise and then remove the blade from the rotating shaft. If unable to remove the blade with a pick, then insert the tip of a flathead screwdriver into the small hole and then turn the blade clockwise and then remove the blade from the rotating shaft. This is a picture of the motor, and in the center is a rotating shaft. Now the motor is open, and the top cover is the front shell, in the middle is the stator, and the bottom cover is the rear shell. The motor has two bearings. One of those bearings, circled in green, is the front bearing on the front shell. The other bearing is the rear bearing, which is circled in green and located on the rear shell. In the space on the outside of each bearing are oil wicks, which look like felt pieces of paper. These wicks need to be lubricated and serve the purpose of feeding oil to the bearings. This is the rotor, which is located in the middle of the motor. The rotor has a total of 4 bushings, 2 top bushings and 2 bottom bushings, which are very fragile and should be removed before cleaning or handling the rotor. For reference, this is a picture of the rotor at rest in the rear shell with the stator. Remove the washer from the rotating shaft. Circled in blue are the 4 base screw locations that will need to be removed in the following step. Remove the base screws with the impact driver. Carefully remove the motor from the rear guard. Circled in blue are the 4 motor screw locations that will need to be removed in the following step. Remove the motor screws with the locking pliers and impact driver. This is the wing nut that will need to be removed in the following step. Remove the wing nut with the pick. Carefully loosen the motor by tapping on the rotating shaft with the rubber mallet. Remove the front shell. Wipe the front shell with a microfiber cloth. Lubricate the front bearing wick. Place lubricant on the cotton swab and lube and clean the inside of the front bearing. The bearing is clean when the swab remains white. Remove excess lubricant with a microfiber cloth. Carefully loosen and rotate the bearing with a foam swab plastic handle. Remove the rotor top bushings. Clean the stator and coils with a clean, disposable foam swab. Carefully dislodge the stator from the rear shell. Clean the bottom of the stator and coils with a clean, disposable foam swab. Attempt to remove the rotor by gently pulling on the shaft. If it won't come out immediately, stop trying to remove it. Turn the rear shell over and lubricate the rear bearing. Attempt to remove the rotor again and keep on repeating this process until it comes loose. Remove the rotor bottom bushings. Clean the rotor with a disposable foam swab and microfiber cloth. The rotor is clean when the foam swab remains white. Lubricate the top and bottom shafts with a clean foam swab. Clean the rear shell with some oil, a microfiber cloth, and a foam swab. Lubricate the rear bearing wick. Place lubricant on the cotton swab and lube and clean inside of the rear bearing. The bearing is clean when the swab remains white. Remove excess lubricant with a microfiber cloth. Carefully loosen and rotate the bearing with a disposable foam swab plastic handle. Lightly lubricate the bottom rotor shaft during reassembly. Give the rotor a test spin. If it's properly cleaned and lubricated, then it should spin freely as demonstrated. Give the rotor another test spin when the motor is reassembled to make sure that the bearings are properly aligned. If you found this demonstration to be useful or helpful, please show support and leave a like and subscribe to the channel. Thank you.